Hello everyone and welcome back to my another tutorial. A week ago I released my first tutorial related with MLTU package, and basically I was training a word detector, it means OCR, and right now I would like to release another tutorial, the continuation of the previous tutorial, and I will use the same MLTU package where I'll create the second tutorial and you might track it along. So basically last time I was training this word to text tutorial, but mainly the issue was that there was a 10 gigabyte dataset and not everyone can allow them to download this kind of large dataset and save it on disk and leave it for training for almost 24 hours. So it also depends what GPU you have, but mainly it takes too long. And usually there is no reason except you have a specific data set where you need to extract specific words from specific images. So basically I decided to create a second tutorial where I'll show you how to train a TensorFlow model to recognize Captcha images. Well, I should mention that these Captcha images will be very simple, only for simplicity reasons, and I'll show you how easy it is to train such a model. And of course, you can find all my code in our GitHub. I'll leave a link in video description. You can follow it. The first tutorial also there, and you can smash the like to this video, subscribe to my future videos. And if you have any questions or suggestions, leave them in comments below. So basically, this is the tutorial I was speaking, and I was introducing you what is OCR, how it works, what methods there are, and etc. But I wasn't developing true OCR because OCR includes actually detecting words in images and extracting all of them, and then give us readable information, some in text file. So right now, I chose to use a specific data set, and here is this kind of person's Captcha cracker data set, where is Captcha images v2, and basically there's around 1000 Captcha images. That's not a lot, but this will be enough for us to train our model from scratch to make a recognition on kind of this data set. And basically I was saying that I am using my MLTU package, so you can download it from PyPy. Of course, it's kind of new package, but for specific this tutorial, I recommend to use this version. And because in the future, while I'm working on it, developing, improving, I'm increasing the version, and future version might not be compatible with current tutorial, so that's why I recommend to use that version exactly for this tutorial. And if you would like to make it usable with a newest version, it's up to you. You can play around with my library. Of course, I don't have much time to document everything, so you might understand me. So basically, let's go to the code and I'll explain everything. Basically, I have here two tutorials. This is my first one, and this is right now I'm recording, and I'll give you a short explanation what it is, what I'm using here, and why. So, of course, let's begin with this train file because it takes everything what you need. So this imports everything we need. It's a data provider. It's to use our dataset in a TensorFlow fit function. Image reader that simply opens the function that reads images, transformers to resize image, add the label them, index them, and add the label padding. Then I use augmenters. This will be used for, of course, for augmentation because we have kind of low dataset. If we want to achieve better results, we must augment them. And I wrote several of these augmenters and we will use. So then we'll use CTC loss. We'll convert our train model to ONNX, and of course we have a training logs somewhere in my models. So basically what I do here, I import my train model, and this is model architecture is in model.py file. You can find it here, and you can play around with it. It's kind of basic architecture that I implemented using some RESTnet ideas, and that's it. Then I use a stow that's kind of very useful package, very similar to OS, but it's way easier to manipulate files which we have on our disk. So basically, before I show you this kind of file where you can download the zip, but if you don't want to download it manually, I implemented a short script that you can use to download these files from this link and save it into the datasets Captcha images v2 folder. And of course, you'll need to wait a little till it completes, but when it completes, you'll have everything extracted and ready for a training. So next, all datasets require some kind of pre-processing. So I simply iterate this dataset, and I need to have a path to the image, and of course I need a label. So the label is a file name. That's the structure of this dataset, and I'm using a vocabulary that's a kind of simple string that holds the unique values of my strings. So this way we'll be able to decode and encode our labels to be used within TensorFlow, because it requires numerical inputs. So then I'm creating my configurations. If I go to my configurations, they're pretty simple configurations that I'll save where's the directory where I'll save my model. That's the date right now. There's the vocabulary that, of course, I will save when I iterate my dataset, because we need this vocabulary when we are deploying our model. And this will be my height and width of my Captcha images. And maximum text length is also going to be updated within the main function from the train.py, and there is a batch size. We can, well, for the story, I can minimize it, learning rate, how many epochs we train, and train workers. And we create this kind of configurations file. Well, as I said, we save everything with the save button. We are creating the directory in my models folder. And if I open, there is a tutorial. This is my next tutorial I'm thinking right now, what I'm great, and that's it. So let's come back to this data provider. That's kind of, you can see that I am giving this kind of list of data sets. There is a path to the file and a label of my Captcha. And for now, I'm skipping the validation, but this is usually used to check whether all the files exist on our disk, which we have. So mainly this is useful if we are not loading this kind of data set, but we have somewhere CSV file that we're giving to my data provider, and we want to check if actually it meets the requirements and all the dataset files exist on disk that we'll use for training. Then this batch size, image reader, that's kind of simple reader that CV2 read and returns image and label. Next, I'm using that transformers. That's because we are using TensorFlow. All inputs should be the same width and height. So we need to resize it. It's also pretty simple object that resizes images like that, and that's it. According to the width and height, and returns our label and label indexer. This takes our vocabulary and we index all the labels in our label and return it as NumPy array. And third is our labels might be different size in dataset. For this purpose, we need to use label padding. For example, if my Captcha is A and I'm adding a lot of different kind of data sets there, so I need to use kind of this one. Okay, and then I use data provider to split my data set by 90%. Its training data will be 90% and validation data is only 10%. And you can see that I create one data provider and this will be equal to for our validation and training dataset. But for training data, we need to add the augmenters because we have pretty small data set, and to train it properly, we need some augmentation techniques. And I add these kind of simple augmentation techniques that is only random brightness, random rotate, and random erode delete. And then I'm creating my model here. So, but first, I would like to show you how my dataset looks like. And if I open this kind of folder, you might see there's a lot of captchas. Well, right now they all are the same length, so there's no huge difference, but you may see that what's the difference here? We can iterate through all of them, and it's pretty simple captchas and nothing else at all. And for us humans, it's pretty simple task, but for neural networks, well, it should train to learn to recognize what we are showing to them. These captchas are very easy to crack, so that's why I'm creating this tutorial, because a lot of you ask how to create a captcha cracker, etc., how to deploy it, and so many things. So let's run my code in a debugger mode and let's go step by step here. And right now you don't need to download this kind of dataset because, well, I already have this on disk, I believe. And yeah, it came, and we can write, for example, what's the length of my dataset? It's 59 batches, and here is the length 7 batches. But this is only the length of batches. And if we're interested how many images we have, I can type length. Well, yeah, we have 10,040 captcha images, and it split it and calculates simply the batch count according we have in configurations. And this is the requirement when we are training our TensorFlow model. So right now I'm simply defining the model, and let's see, I'll define it and let's write a model summary to check how it looks like. It's thinking a little right now. Okay, it was defined, and let's type model.summary output dense. Well, because I will be using CTC loss right now, it's a little different output. It's 52 by 20. But if I look my vocabulary length, maximum length is 5. The only requirement when we are training the model with CTC loss that this parameter would be longer than our maximum length. And I believe that 20 is the... Let's see what it might be. Configurations vocab. Yeah, I think that's the output dimension. That's the length of my different characters in a dataset. Yeah, that's right, and it must be a little longer. It's 20. So everything is just cool because we have a padding token, which I believe we are not using, but this is the requirement with CTC loss. Okay, so right now you can see what is my model, and this is the CVAR metric, and that's specific metric for language training stuff. So many use them, and this specifically gives us character error rate and word error rate, and that's the, for example, how many mistakes made in prediction word according to the true label. And this is kind of one of the most valuable metrics to compare how our model works. It's not good to track validation loss as everyone does. And the second very important step is these callbacks. And well, we know that it's not a good practice to train a model for example, 100 epochs. We must validate, and we want to save only the best model that doesn't overfit and has the best score within the validation dataset. So this actually does this. We are tracking the character error rate within validation dataset. We have a patience that it's 40, and after 40 epochs without improving, it will turn off the training. And then we are saving the checkpoint, and this is well, this must be the same as within this. I'm saving the best model to the models directory, and I name it model H5. And later, when my model finishes training, I convert this model to ONNX format, so it could be ported to different platforms or etc. and run inference without having the requirement to install TensorFlow. For example, in Raspberry Pi, it's pretty headache to install all these huge packages and take a lot of space, the memory, time, and etc. So it's way easier to do so. So then we have a simple logger to track the information of our training and save into disk. And this is useful when we are training our models for hours, for days, for example. And in the future, we want to check how it trained, or we want to compare with another model. Well, TensorBoard, I'll show you the results of the training model, and of course, the reduced learning only too. So that basically reduces the learning rate when we are training the model, and it's a good practice. When it's not improving, we reduce the learning rate, and it might catch better learning curve, learn minor details, and improve our validation score. So yeah, I use it. And that's it. That's the most important callbacks that I recommend to use all of you. And doesn't matter what model you're training, these are the must. And that's it. And then we call the fit with all these callbacks with our training dataset, validation dataset, how many epochs we train, the callbacks, and how many consequence and workers we have. This means that our batches will be prepared in the background while we are running the fit model, and this allows us to use our GPU 100% because you don't need to wait for data to be prepared to be trained on. And of course, we don't need to keep our data in a memory. We can read it at once because, for example, if we have 30 gigabytes of images, they don't fit into memory. We need to read it one by one, and this simply solves this issue. And later, we simply save this kind of information on disk, our datasets. This is only when we are not happy with our performance of our model, and we want to change some kind of architecture, add the dropout or something into our model, and we train it again on the same data set. And this is a kind of CSV files, and then we don't need to load data set as I did here. We simply need to load the configurations, load the validation data, training data, put it here, and everything will work just fine. So that's mainly it about this training loop. And of course, if you're interested, I can run it till the end, and you'll see that it simply starts training. And I open the training, as you can see. Yeah, I hope it will not hang up because I'm recording this tutorial on my GPU. So let's wait until it starts and we'll see what results we'll have. So as you can see, it trains on GPU and I'm tracking character error rate, and that's mainly it what I'm interested. Of course, word error rate is also very important. It tells us whole captcha when it's correct or not. And yeah, it needs some time, of course, to break out this 1.000 character error rate. It might take, I don't know, 20 epochs or etc. But we are not here to watch how it trains. Basically, we are interested to see the training results. And of course, for you, already trained it before, and I will share you the results. So basically, I have my train model on my models, and I go here, and right now it created a new folder when I started training, but I have another model here and that I already trained it, and let's see how it performed. I have these logs, and of course I loaded these with TensorBoard. As you can see, it's right now here. So let's open my browser and let's go to the TensorBoard, and you might see that finished training. I maximized it. I removed this moving, and as I said, it needs some time to start decreasing, and it took me 50 epochs to start learning something. And basically you might see that this orange is the training curve and blue is the validation. And that at the beginning validation was very poor compared to the training data, but here after the 40 epochs you started to understand what it needs to learn actually, and it started correctly predict my kind of captchas. And here is also word error rate that we can also take a look. You can see that, I don't know, for 60 epochs it wasn't able to predict even single captcha correctly, but after it broke this, well, it looks kind of amazing how accurate we can train the model without any effort while implementing it. I don't know, this code took me 1 hour or a little longer to write, and it trained for another hour. We can maybe try it. Oh no, it took me only 30 minutes to train, as you can see, and that's it. We achieved this outstanding results with these captchas. So right now you might be interested. Okay, we have the model trained, we have the ONNX model and etc. What I need to do with that? So let's go back to my code, and of course I have everything for you. I have here tutorials, capture text, and here is the inference model. Of course, I used my library MLTU for this inference, but you might implement it differently. This is ONNX inference. You can open this object. With the help of this object, you can borrow some ideas and implement it somewhere else. So you won't need this kind of MLTU library to install. Because with this library, you are installing TensorFlow, and I believe you don't want that. You might face issues on low-end devices. So basically, here's my predictor model. As you can see, I'm calling the predict. I resize image, expand dims, feed it to the model, and then I feed it to the CTC decoder with a characters list that I saved together with the model with my configurations. That's the importance what I was talking about saving all the configurations within training. That's really useful. You don't know when you might need it. And then I simply created another code here to, well, just simply run the predictions and etc. Oh, sorry. Run the predictions. I can close TensorBoard either. And iterate all this data set. And as you can see, this validation CSV that it wasn't trained, and will run the inference, and we'll see what is the average character rate. So let's run this, and it should iterate all the data set. It's 104 captchas, and you can see it made mistake with less than 1% is mistaken. So compared, it's amazing results, and definitely you can improve this with other augmentation techniques or adding different data set, but that's the main idea how you can do this. And if you would be interested to see what are the images, I can write you a code here, cv2 image show quickly, and the cv2 and cv2 destroy all windows like that. And right now, if I'll run this in debug mode, I may be able to show you what are the captchas. Yeah, of course, I need a prediction text instead of image. It will be way easier. Okay, yeah, yep, that's true. Okay, I can increase the size of this image for you, and increase image size by 4x, and it will be image that's it. That's kind of copilot power. Of course, all the developers should use it, and right now it finished this sentence for me. So let's run it again, and you might see the predictions on screen with the CV2 image show function. Okay, no, it doesn't work like that. Yeah, I made a mistake. Cool. Yep, you can see that there's the prediction of image on top, and let's go through these images. And G2 YCW, well, yeah, that's accurate. That's great. Well, why it's destroying every window for me? I didn't want this kind of... Let's see, again, one more time. As you can see, there's a lot of images that we might use. One more? Okay, one more maybe? That's simple as that. Have you ever thought that it might be so easy? And this is only a simple CAPTCHA. With my code, you can use any variable length CAPTCHAs. Well, it might be difficult with like a Google reCAPTCHA, where you need to click on some different rectangles, boxes with buzzes or etc. But mainly, that's it for simple CAPTCHAs. And can you see how simple it is? Have you ever thought about that? And you can grab my code from my GitHub link that I attached into this video description. You can check my text version tutorial, check my tutorial code, of course, you can use it. And of course, don't forget to like, subscribe my video, follow me on Twitter, Facebook, or etc. And of course, you can add any suggestions, ask questions in the comments tab below. So thank you again for watching. I hope this video was useful for you, and I hope you're gonna love it. So see you in the next tutorial where I'll try to crack something harder, for example, handwritten image text. So we'll see there. Thank you.